Effectively securing your organization and its reputation requires a smarter approach. To maximize efficiency and minimize risk, security experts turn to LogRhythm, the only leading solution built solely for security teams by a security team committed to your success. With next-gen SIEM, user and entity behavior analytics, network traffic and behavior analysis, security automation and orchestration, and compliance, LogRhythm provides security made smarter. The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, your contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. Observit combats insider threats by detecting risk activity, investigating in minutes, effectively responding, and stopping data lost. Give it a test drive at observit.com/securityweekly. Today's determined attackers easily bypass even the most advanced network defenses. Trying to ramp up staff to detect their backdoors can cost thousands of dollars and take months, even years. With Active Countermeasures AI Hunter, we enable junior analysts to detect even the most advanced backdoors in a matter of hours. Sign up for a demo and purchase our product today by visiting activecountermeasures.com/ESW. Active Countermeasures. Make every analyst a hunter.
Hi, this is Doug White from Security Weekly, joining you from Orlando, Florida, and I'm with Mark Russinovich, if you didn't know, who's the CTO of Azure, and so, like, you know, I'm kind of surprised they let me talk to you, actually, but
why?
Well, you know, I mean, it's like little old me.
Yeah.
And,
well, security is an important thing.
Yeah. Well, so you did. One of the things I know you wanted to talk to me about was you were going to make an announcement about confidence computing.
Yep.
So you want to tell me a little bit what a lot of my viewers are not real deep dive people, so they're sort of they would probably like you to tell them what that means.
Sure. So we've got something we've announced. We announced it a while ago as a private preview, Azure Confidential Computing, which is a collection of services, tools, and virtual machine types for running confidential applications. And let me explain what that means. If you take a look at today, the protection, how we protect data. Obviously, encrypting data when it's at rest. Using things like BitLocker or the encryption that we've got in Azure. The encryption of data in use, which is using TLS for encrypting data as it crosses a wire between two applications. But what's been missing up to this point is keeping the data encrypted while it's in use. So as something's processing data, having that data be encrypted so that it's, even if it's leaked, it's not understandable. So up to now, it's not been possible to do that, but Intel and other hardware companies and Azure have come, and Windows Server have come up with technologies called Enclaves, which are effectively black boxes where you can put code and data in the black box and it's not accessible from outside that black box. And there's two types of enclaves that we're focused on right now with confidential computing. One of them is Intel SGX, which is a hardware-based enclave.
Yeah, I've seen that.
It's part of the Skylake processors, and you can create one of these enclaves using special APIs, load code into it, and then ask the processor, tell me what code is running in it. And the processor can tell you this is the code, basically attesting, certifying, this is the code that's running inside this enclave. And while that code runs in the enclave, it's using encrypted memory, which is inaccessible outside the processor package. Even if you have physical access to the server, you can't get access to So you can imagine, and so continuing, the software-based enclave that we're looking at supporting is what was introduced in Windows Server 2016, something called Virtual Secure Mode, which is now called Virtualization-Based Security. So via VSM, now VBS, but a lot of people still refer to it as VSM, which are which are enclaves that are protected by the hypervisor. And when the hypervisor launches one of these enclaves, it protects the memory and doesn't allow anything else access to that memory, even the host partition.
And so that's like a virtualized version of this other hardware thing that we were... Exactly. So for the hypervisor.
So you can get protection from everything except for the hypervisor.
Because the hypervisor's always been sitting there kind of like,
And in the hardware case, you can get protection from everything except for the processor. So what we're doing is, as part of confidential computing, is help enabling an ecosystem and developers to write applications on top of these kinds of platforms. And what we announced this week are the public release of the DC series. So it's D Confidential is the VM type that are SGX-based servers, where when you launch a VM, you get access to XGX Enclave capability. And we've also announced something called Open Enclave, which is an SDK that enables you to write an application that consists of trusted code and untrusted code. And which you can deploy now to your own servers on-prem or into Azure.
Does that Open SDK allow you to get into the black box, or is the black box always going to be the black box? I mean, can you code for that, or is that like something that's locked
No.
out?
So you would write the code that you put in the black box.
Oh, okay, that's
using
what
the
I'm
SDK.
So you could, it's really kind of an open black box at that point, and then you lock it up and
exactly. Now the way that this works for supporting scenarios where you've got very sensitive data. Let's say that I want to do some computation in the cloud, and I don't, I want the protection of these enclaves. I could launch an enclave, load it with a program that was written using the Open Enclave SDK or the Intel. It also has an SGX SDK, and then ask for an attestation of what code is running inside that enclave from the processor.
Is that just like a hash or something that comes
basically
back?
a hash, and it's signed by the processor with
to tell you what it is, so you can track it.
So you can verify, was this signed by a real Intel SGX processor? And if it was, then you know that you trust the code inside of it, inside that enclave. And now you establish a secure TLS connection with that code, and then you can feed it keys. So you've got encrypted data that's sitting there in Azure, encrypted at rest. You give the enclave the key to that data, and now that enclave can load the encrypted data into its enclave and decrypt it, and then process on it. And so that's that overall.
So that's like the end-to-end encryption for an app.
Exactly.
Because I mean, part of that was Meltdown Spectre problem, was the same kind of thing about this private space. So it's a similar problem, I think, that you're trying to solve. Wow, that's cool.
So once you have data like that can be processed like that, that data is fully under your control. From a technical perspective, Azure, Microsoft has no access to it. And
I mean, I can see people wanting that. I mean, one of the things I was going to talk to you about culturally was about how I felt like I've been around a long time, so I felt like that we went from this sort of mainframe model, which a lot of that is what we see with Azure and things like that. The hypervisor model is a lot like a mainframe, and we got promised this bill of goods about decentralized computing, and we could pull everything down and let the users manage it, and all the world would be great, and of course it wasn't. And then we kind of started going back up that tree, and now with things like this, the cloud becomes a kind of mainframe that I dial into from wherever I am, and we have to isolate that. So it sounds like some of this, and maybe you want to talk about it a little bit, this kind of API allows us to reassure ourselves that we can trust our data in the cloud, because the mainframe was always about you're in a shell. And if you get out of that shell somehow, I mean, that was the early days of hacking, was about how do you crash a shell, how do you drop a root shell, and all these things. If you could break out of that cloud environment, which must be being shared with other people, and even among my own trusted people, I'm sharing it. So maybe that is really kind of an idea that you're.
It is. In fact, the way that we look at it in these early days is that customers can now bring very sensitive data to the cloud that they might not have been comfortable with having. In the cloud without this kind of protection. But it also brings in some other interesting scenarios of allowing companies to commingle their data with an assurance that neither one will have access to the other's data.
Because if it's all in an enclave, these enclaves can be isolated in little silos or whatever, so everything that doesn't matter can just become, I like that.
But I believe that we're at the beginning of a new way of developing secure applications and secure topologies. Eventually, this technology is getting more and more rich, and the tools are going to get richer, the management capabilities are going to get richer, to the point where I will, as a customer, want all my data, regardless of the sensitivity, would be isolated this way.
Well, that's like how HTTP and HTTPS developed.
Exactly.
Because initially it was like, well, we get this open stuff, and who cares? And we get this private stuff, and we're going to isolate it, but it's kind of slow. And then all of a sudden it was like, who cares? Let's just put everything encrypted.
Yeah. Once the cost and complexity comes down, then it'll become just table stakes. It's also extremely important technology for the edge. So we're also driving this kind of capability out to edge devices where now, if you talk about encryption while in use, somebody needs physical access or administrative access to the device, and on the edge, it's out in the real world. So, who knows who can get physical access to that device?
Right, and so
you want keys in there to be protected. You want data that's being collected to be protected.
And you have, and that's an ongoing process. So the enclaves, if we get the so that doesn't take so much hardware that we can't use it. Right. So the more things we can put in the enclave, the better off we're going to be anyway. And I guess eventually we get to where the whole black box enclave is is that an object?
It is. What I see eventually happening is you'll have nested types of enclaves. So
or container,
my enterprise might have an enclave, and then within it, organizations have enclaves.
I know, I get it. So there's so I got a whole enclave just for like my web instance that's running right now on the edge. And no, I like. I'm sorry, I'm thinking it through. So it's like you just introduced it to me. So I'm like, well, that's cool.
No, it takes a while to wrap.
And I mean, there were a lot of mainframe ideas in that, though. I mean, that kind of stuff persisted from back even in the 70s. You were seeing those concepts in mainframe. A lot of times it wasn't possible, or there wasn't enough hardware to do it, or it was really simplistic. But I mean, that stuff dropped out, and now we're building back up to where we started.
Exactly.
Which is good, because we need to get by. I was saying we shouldn't leave this place a long time ago, but we kind of worked our way back around to that. Well, that's an interesting announcement. What day is that going to be announced?
It was and just announced this week.
Oh, it was just announced this week. I'm sorry.
Yeah, Corey talked about it in his session. Corey Sanders in his infrastructure session on Monday.
Well,
but the Enclave SDK will be available in a few weeks.
And so that infrastructure session is available on the stream from Ignite, so you can go there and get it if it's something you're wanting to watch later. You can get Corey's session.
And actually, I'm doing a Microsoft Mechanics show tomorrow morning, which will also be live streamed.
What time is it? Well, we won't get this aired, but
I think it's like 11 a.m.
But it will be in the archive then. So even though it's live streamed tomorrow, but we're not live now, so all of you missed it. So too bad. But cool. That's really interesting. I can't help but talk to you a little bit about your book.
Sure.
Is that okay?
No, absolutely. Please do.
So if you don't know, Mark wrote a series of books about a lot of things that a lot of you would probably like to read about, because when you read these books, they're very close to home. So a lot of times you read tech books about threats and things, and they're written by people who probably don't, just like TV shows or movies, they don't really know very much about these things. But Mark does know a lot about these things. And one of the things that came up to me right away, I mean, the first time I ever read Zero Day, when I picked it up on the first page, it was so, I don't know, it kind of hit me kind of hard, because way back in the 90s, I had a radio show, and my radio show was about Y2K.
Yeah.
And Edward Jordan had written his, famous treatise about the end of the world, and the end of the world being caused by Y2K. And this evening news person came to talk to me, and they wanted me very desperately to talk about plane crashes, because that was something that Edward Jordan had said, that all these planes are now controlled by computers and they're not going to fly. And I didn't get aired because I refused, just like you did in your book. At the last minute, the pilots, which is what I was saying on the evening news all these years ago, the pilots finally flew the damn plane. I was like, and which was what happened. I'm sorry, I don't mean to spoil the first page of Zero Day for you, but that, the pilots eventually pulled the plane out at about 2,000 feet or something like that. So I really wanted to talk a little bit about the impact of this, and it sounds, obviously you're addressing it with your enclaves and all these kind of things. Y2K was a big deal, and it didn't amount to much in the end, but the idea of it, I think Edward Jordan was just a little early. Yeah. Because today, with things like Azure, every time I talk to a client about something like that, whether it's Azure or some other hypervisor type world or cloud-based world, I start thinking about the same thing you were addressing there, which is what happens when we're all in there, and we're all in the same room. Everything's here, and somebody starts compromising it in whatever manner they whether it's a Y2K thing or it's something more like Zero Day. I won't spoil the rest of the book for you. Read it. It's on Kindle. You can get it. And I mean, what do you think about that? I mean, is that something that, I mean, obviously you think about those kind of things.
Yeah, well, going back 6, 7, 8 years ago when I had just started in Azure and companies were still just starting to look at cloud, I had that question all the time of, wait a minute, I'm small,
right.
I have low profile, I'm not an interesting hacker target. Cloud.
Put me in there and I am.
Yeah, now I'm in there, it's a rich, juicy target. So am I less secure if I go to the cloud? And my answer is the same now as it was then. In fact, it's more adamant now for a couple reasons, that you're going to be more secure in the cloud. One, that there's no company that has a low profile when it comes to hacking. And Robert Mueller, former FBI director at RSA conference, famously said there's two types of companies in the world. There's companies that have been hacked and companies that don't know they've been hacked.
Yeah, I completely agree.
Yeah. So, and that's really a fact of life. No matter how small you are, you're a potential target. And we've seen examples of small companies getting hit with ransomware. And you might be just caught in the general blanket of somebody going after stuff, or you might be specifically targeted.
Right.
The cloud provider, if you take a look at the security budgets and the expertise of even many enterprises,
right,
they don't have the budgets, they don't have the skills, and they've got such a complicated infrastructure typically that it's extremely difficult to keep a secure posture. And I'll just, for anybody out there that claims or believes they do, I'll just throw at you the question, do you know what your current patch level is across all your servers?
Exactly.
Can you go tell me right now?
Right.
And if you take a look at a cloud, from the homogeneity and the API-driven nature of the cloud platform, we can confidently tell you the patch level of our servers at any point in time.
I like that.
And we also have automated patching systems in place that continuously are patching the whole platform. So from an automation perspective, from an inventory management perspective, from an audit perspective, and then from a controls perspective, that is our business. Our business is built on top of trust, and so we've invested heavily. In fact, the laptop that I've got with me is called a secure administrative workstation. We cannot access production from an everyday laptop. We've got to go through this system, which is locked down, so only certain scripts are allowed to run, only certain programs are on, only certain websites are allowed to be accessed. It's VPN controlled.
Mainframe.
It's constantly logged. And there's machine learning algorithms that we've got looking at activity on it to see if there's any sign of compromise. And then if I want access to production, I've got to request access through our just-in-time access control system. It gets approved. I get limited time-bound access to production just for the resources that I need access to. And it has to be correlated with actually an incident ticket.
And I would call it back to the mainframe. I mean, because that was exactly, I mean, all this obviously much better orchestrated than a mainframe built in 1970, but the idea is the same, that you have dev and prod.
Yeah.
That was an old mainframe idea, was that developers sit here, they can't get out of this box, and no matter what they do, they can do kind of crazy stuff, but they have to cross this little boundary that's locking them out and to get into that production box. And if they don't cross that boundary, and it may have just been a guy named Chet sitting there saying no.
Yeah.
I mean, in the old days, but today we have many, many pieces in AI or whatever we can put into place to control it, like you were describing, between your box and actually getting out there into that production environment or something like that to protect it. And I've been telling people the same thing that you said for a long time about the cloud, because I kept getting a lot of pushback on, the cloud is just a huge threat. And I'm like, look, your business, you have no idea, because I deal with a lot of smaller clients.
Yeah.
I mean, you deal with a lot of bigger clients.
Yeah.
I deal with a lot of smaller clients who come in and they say, we've got 5 servers. And I asked them the same kind of question, like, what server, what patch level? And they're like, oh, I don't know. The guy named Vinny that installed it, I think he patched it. And when was that? 5 years ago.
Yeah.
Oh, yeah. So when was the last time you patched? I don't know. Maybe 5 years.
Yeah.
And they have no idea. And I'm like, so look, if that was sitting on this very, very homogeneous environment in the cloud that was being controlled and that had underwriting, which is a big word I like. And, wouldn't you be better off? I mean, it's out there and it's protected. And when the building falls in, or when there's a fire or there's a flood, I had somebody call me the other day and they were like, what do you think happens when there's because they had seen some of the flooding and they were like, well, what if that happened to us? I'm like, it would be bad.
Yeah.
Because you got all the server racks down in the basement. And there's a school district, and they have all these server racks, and they're like, well, all our grades, all our records, and everything. I'm like, yeah, wouldn't it be better if that was in the cloud? Because they had been very resistant about that for a long, long time. So obviously, I think logically we all end up on the same page anyway, and which is why I'm not sitting here disagreeing with you. I mean,
it's not just the infrastructure and the fact that we spend $1 billion a year on cybersecurity. A lot of that aimed at infrastructure, cloud service security. It is also the fact that you as a customer can take advantage of the API-driven nature of the cloud to better secure your own applications.
Yep.
So something like Azure Security Center, for example, like if you pointed at any application in your enterprise, if I pointed at one and I said, is that thing behind a web application firewall?
Right.
What ports are open?
Right.
And you'd be like, okay, let me go and figure it out, and you'd come back a few days later after running some scripts.
And that was another thing. I mean, this was years ago. I was talking to people about cloud ideas because I was experimenting with that kind of stuff. We were just talking about VPNs. And again, I was stealing every bit of this from the mainframe world because it was the same idea. But I had a client, and they were wanting to put all their servers in one place even. It wasn't even a cloud idea as much as it was like a sort of internal. They were just like, could we put our servers here? They're safer. There was this nice, away from the coast, away from, earthquake zones and all these things. And I was like, well, yeah, why wouldn't you? I mean, if they're all there, and now you just got one pipe that goes in there from this one place. Whereas now you're sitting in this big office, there's a switch, and what happens if that switch isn't set up right? And it's like suddenly people can get into this and then get into that. But this is now one pipe that you can monitor, that one single pipe that everybody's going through to get to that place. So all you got to do is defend that one little fort instead of defending all these forts that are scattered. Because I was never a big decentralized fan.
Yeah.
Or distributed. I like the idea of the processing distributed, but I don't like the idea that it's out there and anybody can get to it. And there's a lot of problems with that. Okay.
Yeah.
Sorry, I can rattle on about this. I agree with you very much. I read a bunch of your stuff, and I was just like, okay, yeah, we're right on the same page with that. So I had a question. This is more of a cultural question for you. So if you guys don't like it, tough. But I'm always thinking about society, and when I get asked these questions, because I'm a college professor, so I get asked questions about government, and I came from sort of a government background, so I get people call me, in school. If you go to school, they're going to teach you reading, writing, and arithmetic, but they don't teach technology. I mean, they try to, and I know that some of it's about budgetary limitation. How do we change the cultural world so that when you and I are talking about this, that a judge can understand it? Because we have all these people making laws and rules and policies, and most of these people, that was never taught to them.
Yeah.
So they're calling me saying, I've literally had people who make laws call me and say, this cloud thing, what is it? They have no concept of it. It's not even like they're saying, is that like a mainframe? It's just like they don't even know what it is or why it should exist. Well, how do we do that? How do we get from where we are to where we're teaching people something they use every single day of their life? We teach English literature, for instance. Every high school student in America takes English literature at some point in their life, every high school graduate. But they don't take technology. Some of them do, but they don't have to.
Yeah.
And I had to take flag football when I was in school, and I don't know anything about football, and I didn't really want to know, but I didn't have to take technology. And that scares me a little bit because those people become lawyers, and then they make rules.
Yeah.
What do you think about that?
Well, are you asking me from Mark in general, what should society do, or what does Microsoft
No,
do?
this is a Mark in general. I'm asking a smart guy to tell me something. If you want to give me a Microsoft answer, that's cool too, but I'm really asking you because like I said, I read your books and it gave me a feel for like where you think, so I thought that I would rather hear what you had to say about it.
Well, this is an incredibly hard problem.
Of course, right? That's why I asked you. I was like, I'm sticking him with it. I don't know the answer.
Yeah, Bill Gates is working on education, and he's having a tough time with it. And he's got a lot more assets at his disposal than most people.
Well, let me ask it a different way, though, to get you off the hook a little bit. Do you think that cultural is the solution to a lot of this?
I do. And I think that you're already seeing infusion of technology into the classroom.
Right.
So at least,
that's
whether it's laptops that the students are doing homework on or labs on, or that is proliferating across our schools. So they're getting exposure to technology in a more structured way than just taking a laptop home and doing whatever. I think when it comes to the underlying technology, which I think you're after, because sure, people can write PowerPoints and search the web and do research, but actually coding, you're seeing more simple kind of coding camps now move into schools. You're seeing companies, Microsoft itself is trying to promote the teaching of computer science in school.
No,
and I think one of the big challenges there is just lack of skilled teachers, educators.
Right.
So we're trying to augment the existing teacher workforce through a program called TEALS. I can't remember what it stands for, but it's.
I've seen that. I don't.
Yeah.
What is that? I don't remember.
Yeah,
I've seen that program. Now, I went to a presentation about it last year, but I don't remember what it.
Yeah, but it's Microsoft employees
it is,
can volunteer to go teach at high schools.
Right.
Computer science, computer technology.
And we need that.
Yeah.
Because like the state of Rhode Island, where we're based, 2 years ago they passed a rule that said that every school must have computer science in their curriculum.
Yeah.
And then that was it. That was the end of the letter. It was like, where's the 5,000-page budget that's attached to this? Because I was on one of the committees that was reviewing this, and I had high school principals calling me saying, what should I cut? And even if I cut it, should I take an art teacher and have them? And that's exactly what they ended up doing.
Exactly.
Was they were taking an art teacher and saying, now you're teaching C programming because that's just the way it is. Tough. We're not doing art anymore. Now we're doing C programming. So get over it. And I mean, I know those are difficult problems. I'm sorry, I didn't mean to put you on that total hook right there. But I was having fun with that. But what do you think comes next? I mean that's sort of my, I guess, penultimate question for you is. Yeah, we're getting there with the cloud. We're going to secure it. We're going to use this Enclave system. We're going to lock it down. What comes next? I mean, there's obviously another threat out there somewhere.
What comes next as far as threats?
Threats.
Well, certainly the cloud will become it. I mean, it's already a juicy target. It'll become more of a juicy target. Yeah, the stakes are getting higher. Our investments are deeper. So security is never a never-ending, challenge. So, I think you say what's next. It's more of the same. Actually, just ratchet it up and.
That's good. No, I like that answer. I like the answer that more of the same because until I mean just like physical threats. So I mean we culturally understand crime.
Yeah.
I mean we can't solve it. We've been trying to solve it since cave people were running around, and we've never solved it. People are still getting mugged. People are still getting whatever. So I don't think we'll ever, and I've had to give that answer to a lot of people, which they don't like, because, you get asked again by somebody sitting with a lot of, robes or stars or whatever, and they say, how do we fix a problem? And you say, you don't. I mean, you have to decide where on the continuum you want to live.
Yeah.
There is a place where you could fix it. It's not a very fun place to be.
Yeah, turn off your computer.
Exactly. Yeah. Turn it off or put it in a steel box and weld it shut and never use it again. Good, secure. Or you could be in the Wild West, but nobody really wants to be there either. So you have to find where on that scale do we really want to be. And then it turns into money. So it's like you can move that arrow with money and you can move it with culture and ideology. So
yeah, and if you take a look at the capabilities that a dollar can give you from a security perspective, they've continued to increase. I mean, if you take a look at technologies in Windows, like control flow guard, no execute memory for even kernel drivers. I mean, the virtualization-based security, the levels of defense have been increasing. So a dollar can get you a lot more, and in the cloud, it's even more magnified. But there's always going to be a weak link somewhere, whether it's human or technological. And so we have a philosophy of assume breach at Microsoft. Yeah. Which is we're going to get breached. So we're going to put up great defenses. We're going to get breached though. So detect it as quickly as we can. Right. And put in systems that can.
Same thing as physical law enforcement security. It's like you're going to have it. You might as well just get used to it. So decide where you want to be. Yep. How fast you want to fix it. Or do you want to fix it and then just live there and as long as you do that, that's the answer.
And you've got to, if you're saying I'm going to put up a great wall and that's what I'm going to spend all my money on, the day that somebody climbs over that wall or digs a hole underneath it or finds a way through it, you're really in big trouble because you never planned for that.
Because I was walking on that great wall last year, and that wall was built a long time ago, and it wasn't effective then. And walls don't tend to be effective. You have to learn where you want to live and deal with the consequences of that. Mark Russinovich, thank you so much for joining us on Security Weekly. It is a real honor to talk to you. So I appreciate your time so much.
My pleasure. Thanks.
Thank you.